Hello everyone. So today we are going to see about the design pattern called simple factory design pattern. So basically, in design pattern we can categorize the design pattern to three types, like creation design pattern, behavior design pattern, structural design pattern. So creation design pattern deals with the problem which are related to creation of objects, and behavior pattern deals with the problem which are related to behavior of the class, how it should behave. So that problem, and structural design pattern deals with how the classes should be structured so that it can be easily maintainable and scalable. So that is structural design pattern. So today we are going to see about the simple factory design pattern. So the simple factory design pattern is a creational design pattern. Okay, so the name factory says there is a name word called factory in this design pattern. Factory means we already know it's like production unit, so it deals with the creation. So in simple words, we can say it deals with the creation of objects. So first we will see what is the problem we are going to face and how we can use this design pattern. So when we want to separate out the creation process from client code, so it it not only client code, can be any code or any module. So if you want to separate out the creation process, then the factory pattern comes to the picture. So we can use factory pattern. So factory pattern, I am simply saying factory pattern. So factory pattern is of three types, like simple factory, factory method, and abstract factory. But today we are going to see about only this simple factory. So the problem is, when you want to separate the creation process from the existing, like any module or client code, then we can use the simple factory. And already, as I said, the name factory is there, so it deals with the creation issue. So this is the problem statement we are going to face, like creation of similar objects. If we have like some objects which are similar to each other, and when we want to create those similar objects, we can abstract out the creation process into a separate module. So this is the problem we are going to face in our code, and we can solve using the simple factory design pattern. So what it will do is, it will if we can create a separate module for creation of similar objects, and we can abstract out the creation process. So do we have any example for that? Yeah. So for example, consider a restaurant. So restaurant can have a system. So once we go to a restaurant, we can have three types of orders. So like first one is dine-in order. So then we can have takeout order, and third one is delivery order. So once a person reaches to a restaurant, and when he does then order, that need to be created in their database, and the system, they need to create an object for the order with. So based on the user, whether it is dine-in or takeout or delivery order, they need to create an object and store it in DB. So all these are type of different objects, but all are similar. Like order is all these are orders only, but they are of different types. So instead of creating separate classes, we can create. So uh, okay, let's do. If we don't know the design pattern, what we will do, let's see that part of code first. So if we have order, based on the user input, we need to create some of these three orders, and we need to process it. So let's see the code, how it looks. So I have already written the code. So inside main function I'm going to get the type of the order from the user. So based on the type, if it is dine in, I'm going to create an order of type dine in, and then I'm going to process the total. Then if it is takeout, then I'm going to create a takeout order and process it. And if it is delivery, then I need to create a delivery order and then process it. So all these three are different objects. So if you see the class, I have created three different classes for each type of order: dine in, takeout, and delivery, and each is having process function. So based on the input, we are creating the object and processing it. So consider it can be a main function or any other module also. So yeah, above this we can have some other code which is responsible for some other thing, and below also we can have some some other things. Okay, so this is the code we have written. So if this is the requirement we have given, like order requirement, so like we will write like this only. But uh, whatever code we are writing, so that should follow the solid principles. So we need to check if it is following the solid principles or not. So let's see if it is following the solid principles. So in solid, each of the letter denotes each different principle. So first one is SRP, single responsibility principle. So we can see the code. So this is the module. Here we are having process, creation process. It is responsible for creation as well as other, like before creation can be of any, it can have any other responsibility also. So and after this can have any other responsibility also. So it is not having a single responsibility. So clearly it is violating SRP. Then OCP. OCP means open for extension, close for modification. So if you see a few years back there is no delivery, no Swiggy or Zomato. We just had dine in or takeout. So recently only we have added delivery. So in future it can be of any other type also, like order can have any other type which we may not know. So if we have any other new order means then we need to add if else condition here. So during testing we need to test the whole module. For just adding new type we need to do the whole testing, so it is not easily maintainable. So we are touching the existing code, so OCP also violating. So Lisco substitution principle, here there is no Lisco substitution principle because then we are not having any base or derived classes. And interface segregation principle, there is no interface we are using. And dependency inversion principle. So dependency inversion is higher level module should not be dependent on lower level module. So here this module is the higher level module, and this order like dine in, takeout, delivery or lower level module. So it is directly dependent on the class type, like lower level object. So this is also getting violated. So as we see, we are clearly violating all the solid principles. So it is not in a good code. So we have not written a scalable or maintainable code. So that's why there is a design pattern called factory pattern which will solve these problems. So how we can do? So as I already said, like this simple factory pattern, how what it can do is it can separate, abstract out the creation process. So this is the creation process we are having. So this we need to separate it out. Okay, and we can separate it and we can write it in a separate class. Okay, and creation of similar object. Similar object means how we can make these objects a similar object. So here these have no relationship on each other, but if these are similar object means we can create a base class like interface order, and we can derive these dine in, takeout and delivery from that order interface. so that this can be of same type. So we can make it these objects as similar objects. So we can introduce the interface, and we can create concrete classes for this dine-in takeout delivery, and so that we can make this object as a similar object. Abstraction is we can separate this creation process into separate function, separate class. So that's it. So this is simple design factory. So let's see how we can make the same code converted to simple design factory. So this is what I have already written the code. So I have created a same code only, but I have introduced the interface which has process function, virtual function. I order is the interface, and dine-in order, takeout order, delivery order are getting inherited from this interface, and these are implementing this process. Okay, and obviously I have created a factory class, and here inside it I have created a static method which will return I order pointer. So inside this I am having a function create instance which takes the input type. So based on the type it will create the object and it will return the interface pointer. And here we will in client code we will get the type from the input, and inside this factory static method we will call this static factory method, and we will pass the type so that it will return the I order pointer, and using that we can process because it is inherited from the same interface. It all should have process method so that we can easily process this. So this is the same code with uh, simple design factory applied on it. So let's see now whether this solid is now it is getting violated or not. So SRP. So now we have or here the module, this module is not responsible for creation. We have separated out the creation process. Okay, so here whatever needed that only will be present. And here in factory we have introduced a new class factory. Here also you need to see SRP is followed. So here SRP is followed. So it is responsible only for creation. This class is responsible only for creation, and SRP single responsibility principle. In other words, we can say there should be only one reason to change. So if you see here, the order factory class can be changed only if any new type have introduced or new type like any existing type has removed. So we can just remove the if else condition so that we can test only this order factory class. We no need to test the entire module. Okay, so this is the only reason to change one. Okay, so this is getting not violated after applying simple design factory. So OCP. So OCP, if you see uh, here, if any new type is added, we need to modify this in this part alone. But still, we are modifying it. So it is partially violated. And here we are having this curve principle. So wherever we are using IR like dynamic order, we can use I order. So that's what we have done this here. So this is not getting violated. And inversion segregation principle. So we have created a small interface. So we are not creating a big interface. So this is also not getting violated here. And finally, we have dependency inversion principle. Here, dependency inversion principle is followed. How in previous code, the main module is directly dependent on dine-in order or that particular type of order. So if you see in the new program, the main is not dependent on any type of order. It doesn't know which order, it just deals with the interface only, abstraction layer only. So the higher level module is not dependent on the lower level module, instead it is dependent on the abstraction layer only. So DAP is followed, so it is also not violated. So this is about simple design, like simple factory design pattern, guys. So this is the problem creation of similar object abstraction of creation process. So that's it, guys. Thank you.